So hello everyone. Today we are here to I Ajay and Sujit with me would be delivering session on distributed cache with dotnet microservices. So mainly we would be talking about the caching thing that how we can implement it in our project. It's not about dotnet really. We can do it in any project, maybe in Java as well, dotnet as well, Angular as well. Okay, so let's proceed with it. So these are All right, okay, this is our agenda. First, we will go through the caching. Then we will go through advantages and in real life example of this caching. Then cache, distributed cache. Thereafter, we will learn about the patterns and policies that are there in caching. Thereafter, we'll go with some of the eviction techniques. By eviction techniques, I mean if we want to delete some data from cache, that is no more required. Then we'll go through Redis cache, the one of the caches. We have in-memory cache, we have Redis cache. Then we learn about the benefits of this Redis cache in microservices. Then we'll learn how to set it up, and we will have a short demo of 5 minutes after that. So let's start. Yeah. So introduction to caching. What is it? So basically, caching is nothing but a technique to temporarily store frequently accessed data in memory for quicker access. So as we know that in our projects, whether it is in Web API project, whether it's a MVC project, we do make database calls, right? Why we make database call? We make database call to retrieve the data, some kind of data, maybe some employee data, some consumer data, right? What if the frequent data that we are making a calls to database, why not we store it in cache? So see, in database, if whenever you make a call to database, whether it's a SQL Server or Cosmos DB, there is a cost associated with it. If we go and check the execution plan of each query, there is a cost associated, and we know that on this particular day, or most of the user, I mean to say multiple user of that same application would be accessing this kind of data daily basis. We would instead store it in cache, so that whenever a call comes, we would rather making a call to database to retrieve that data, we will retrieve the data from cache memory. So what are its advantages and importance? Performance, the data would be retrieved faster. We need not make any database call. So that's why we would be having a reduced database load, fewer database queries, reduced server load, and enhance user experience. So user experience would be very good because we have retrieved the data very faster. Advantages of this. So let's take a real life example, maybe Instagram or Twitter, we can call it formally. Now it's X. So scenario is something like when a user visits another user profile page on Instagram or maybe Twitter, he or she can see the user detail and recent post of that user, and what is the follower count of that particular user, right? If I'm not doing any caching, what will happen? Every time a profile page is loaded, the app will have to query the database to fetch all the information, to fetch all the post, to fetch all the count of that particular follower. And what will happen in this case? It will slow down our app and increase the load on the database. But with caching, like frequently accessed profile, let's say I'm accessing profile of Virat Kohli, I'm accessing profile of Sachin Tendulkar, like I mean some of the celebrities which are frequently accessed. Why not I store the data in cache instead of making a call to database and hanging the database, right? So follower counts, recent post, all are stored in a cache. This what will happen now? This means the data can be quickly retrieved from cache itself instead of making the queries call to database. I need not make any database call to fetch the follower count. I need not make any database call to get the recent post of Virat Kohli or whatever. So caching here, it's benefit. This is the benefit of caching. So performance improvement, profile page will load much faster, right? Database load, there is no database load because we have retrieved the data from cache itself. User experience, obviously user experience is itself very good. At example, yeah, when a user views a popular tweet or Instagram post, the post details are cached, right? Subsequent views retrieve data from cache, ensuring a swift user experience and maintaining database performance. Nowadays, we know that we are getting reels on Instagram, we are getting a number of memes, but there are some memes that shoot up very high and that are really liked on a single day, and they are like those kind of things are cached instead of getting retrieved from database again and again. By using caching, we can Twitter, Instagram, Twitter handle million of users accessing the same content simultaneously, ensuring a smooth and responsive experience. We all know that at a time, number of multiple users are accessing Instagram, Twitter, right? It's not possible to make to make multiple calls for the same thing, for the same post into the database. This would hang our database. Instead of to make the user experience beneficial and fast, cache is the something where you just go by the key and retrieve that particular value there and then and there itself. Then and there itself, and there would be less load on our database. So kind of a diagram. So see, these are kind of three users which are sending request to server, and this request would be like served, and this will hit our database and data would be retrieved. This is without caching. Now with caching, if the three, let's say there are three users, they are making a call to server with some API call. So maybe let's say for an example, retrieving the data only, some kind of post, right? Now request one, if it is not available in cache, what it will do, it will go to database and retrieve that value. But for request 2 and request 3, we know that but that particular data lies in the cache memory. So this request would be served from cache. It will go into cache, it will retrieve the data and serve these all three clients, request 1, request 2, request 3. So these request 2 and request 3 initially would be faster. Request 1, as because request 1 didn't having any data in the cache memory, that's why it went to database. So we would be doing like this only. If we can identify that our data is in cache memory, we would fetch it from there. Otherwise we would make a database call to retrieve the data, and accordingly, as per our business purpose, we will store the data in cache if it is frequently used. So importance, like in industry, like we work on client side projects, so it would be scalable. I mean to say scalability. It will handle more users and data by adding more servers. High availability, ensure critical services stay online, like health services, stock markets, military. These are some of the essential services. And if we are let's say we are running some kind of cron or job, and we are making multiple hits on military server or multiple hits on stock market, server would be hanged, all finished, right? So this cache is a very good technology. uh, Fault tolerance, maintain operations even if parts of the system fails. Yeah, so even if let's say our db calls, let's say our db is not working, right? But the same data is in the cache, so we can obviously retrieve from the cache. We need not need that db call. Real world examples: health services, stock market, and military, as I mentioned. So in hospital, we need constant access to patient record. Distributed cache ensures these records are always available. By distributed cache means there are multiple cache that are defined in our project. Cache is not like just a particular single thing. There can be multiple caches also that we can define in our like Redis. Redis is a kind of a distributed cache. Stock market, stock prices need to be updated in real time without delays. Distributed caching helps in providing fast and reliable access. In military system, we need to be operational at all the times. Distributed caching ensure data is always accessible, even in case of server failures. So let's say if there is only single cache that I have and all the data is there in that, and if that particular database or that particular cache fails, so all the data is gone till it is not up, right? So that's why we are having a distributed cache where the data is distributed among multiple caches. Types of cache. So here are the two types of cache that are supported in .NET Core. The first one is in-memory caching, which store data in memory of the web server and is mostly suitable for only single server application. Distributed cache that I was talking about, it's like storing data in shared cache, accessible by multiple servers, and is suitable for scalable high availability application and microservices architecture. So example are Redis and memcached. Let's move to distributed cache. A distributed cache is type of a cache where data is stored across multiple server or nodes. These nodes can be in the same data center or spread across different data centers around the world. So we can have multiple centers, multiple nodes, right, where the data can be spread up. And this is how distributed cache can be handled. And this is how we can retrieve data from cache memory. Benefits, some of the benefits are like scalability, high availability, fault tolerance. If I give an example, like in explanation, we can add more servers to handle more data traffic. If we know that there is more traffic coming in, accessing this particular website, we can add more servers, right? Example is if a website gets more visitors, more cache servers can be added. High availability, data remains available even if some server fails, because we have multiple caches and distributed one. Example, if a server goes down, other server can still serve the data. Similarly, for fault tolerance, the system will continue to function despite server failures. If a server crashes, data is still accessible from other servers, because we have data like our cache data distributed across servers. Now coming to caching patterns and policies. These are some of the common caching patterns: cache aside, read through, write back behind, write around, refresh ahead. So I hope like most of us have read that subject operating system, in that we might have studied these caching patterns, and that particular we had na FIFO, LIFO and all that kind of stuff we might have read. So you would be able to relate it here. So what is cache aside? So basically the application checks the cache first. As I mentioned previously, if it will check the cache first. If the data is there in the cache memory, it would access it from there. Otherwise, it will go to database and retrieve the data. Thereafter, it will store it in cache and return it to the user. Why it will store in the cache, that all depends on the business, because let's say that was a profile, maybe if I give an example of Instagram only, that was a profile that was accessed like frequently. If India wins the World Cup, everyone would like follow Virat Kohli, or everyone would search for Virat Kohli, something like this. So that particular profile would be stored in cache, and it would be returned to the user if anyone is accessing Virat Kohli profile. So best for ready heavy data that doesn't update often. Read through. The next one is read through. The cache checks the database. If data isn't found, store it in cache and return to the user. Write best for data that benefits from lazy loading. Write through. Data is returned to the cache and database at the same time, keeping both in sync. Okay, so let's say we are maybe saving some data into database. So this write through, what it will do, it will save the data at the same time, both in the cache memory as well and the database at the same time, keeping both in sync. So next time when we try to access the data, it would directly retrieve from cache itself, because it will find in cache in the very first call itself, because we have stored it. Best for very heavy application needing data consistency. Write back behind. Data is returned to the cache first and queued for database updates later. Okay, so in this basically we write the data in cache first, and thereafter we basically run a job, or maybe queue the data, that it would be saved into the database later on, so that we can allow faster writes, but with the risk of data loss if the cache fails. Write around. Data is written directly to the database. On read, it fetches from the database and store it in cache. This is best for applications that don't reread recent data very often. Refresh ahead. The cache refreshes the data before it expires, ensuring the latest data is available when needed, reducing latency by keeping the cache up to date. So for this one, refresh ahead. So whenever we store the data in cache, we do set the expiry time as well. Maybe let's say we are storing some data in database, we have stored it in cache after a very first call, but that data, we know that particular data in the database would get updated in maybe 1 hour or maybe each day. So we would be setting an expiry date for every data that we stored in cache. We are available with some of the methods and function and the time calling that this data should expire from cache. These are some of the caching eviction techniques that we would be moving to now. So we have least recently used, least frequently used, which is LFU, and first in, first out, which is FIFO that I just mentioned. So whenever our cache is full, we use some of these techniques, last in, first out, most recently used, to empty our cache. So how this work, least recently used. So basically we remove the item that haven't been used for the long time. I know that this particular data is in cache, but no one is using it, no one is accessing it. So I would delete it. Okay, so we can keep track of the items when the item was last used or last accessed, and accordingly we would delete and empty our cache to make way for new items to be stored into the cache. Least frequently used, remove items that have been used the least number of times. So maybe in this particular scenario, we would remove the item that have less call, that are getting accessed but very least number of times. So it keeps a count of how often each item is used. If that particular data that we are storing cache, that is getting used only 10 times in a day, that doesn't make any sense to be stored into the cache. So we can remove it. First in, first out. we remove item in the order they were added. Okay, so let's say our cache stored 100 data, I mean to say 100 rows, it 100 data it stores, and now we need to make a way for the next data. So how we will do it is, the data that was first inserted would be out first. Getting me? Like you can call it stack, last in sorry, first in first out. You can, yeah, first in a queue, like a queue, last in first out. This is a LIFO. Remove the most recently added items first. It is similar to a stack. The last item that is added is first to be removed from when the cache is full. So the last item that we just added, we would remove it first to make way for the new one. Most recently used removes the item that have been used most recently. Okay, so in this so this depends, see, this depends what our business purpose is. Accordingly we would empty our cache and use these techniques. So maybe for this most recently used, we need to remove the item that have been used most recently. We know that this has been used most recently. It may be business purposes that we don't want to use it now, so we can remove it. We will keep track of items when items were last used. When the cache is full, this would be the first one which would be removed from the cache, the most recently one. This all the scenarios depend upon the business purpose, how they wanted to empty the cache. Now coming to what is Redis. So basically Redis is nothing but a remote dictionary server, which we call Redis cache, is an open source in-memory data structure that can be used as a distributed cache, database, and message broker. Basically, it is used to store the frequently used and some static data inside the cache and use and reserve that as per user requirement. There are many structures present in the Redis which are which we able to use, like list, set, hashing, stream, and many more. So basically, we can create a list or a hash table to store that particular data with a key value pair into the Redis. What are the key features? So like in memory storage, data is stored in RAM for fast access. So our RAM, I mean in a laptop or CPU, we do have a RAM, right? There is a small kind of a cache memory where we stored this data for fast access. Data structure supports strings, list, set, sorted set, hashes. It supports bitmaps as well. I have worked on list and hashes for storing the data in sorry, this Redis cache. Persistence option, data can be saved to disk to prevent data loss. High availability, Redis Sentinel provides high availability through monitoring and failover. Scalability, Redis cluster allows horizontal scaling by distributing data across multiple nodes. As we discussed previously, we can distribute our data across multiple nodes or server to make it more scalable. So let's say we have 100 chunks of data, we can distribute it across our 100 servers. Let's just an example. So maybe each server would be having just one node, one data, right? Whenever user tries to make a call and access the data, it would be served him in less time. Benefits of using Redis in microservices. So like performance, one is the performance, which is like speed. In memory operations are much faster than the disk based operation. Low latency, immediate response would be there for read and write. Decoupling, reduced dependency. Microservices can fetch data from cache instead of hitting database every time. Availability, failover. Whenever this like our database call fails, cache is always available. Redis Sentinel ensures availability by automatic failover. Replication, data can be replicated to multiple Redis node, I mean to say multiple servers. Now coming up to setting up Redis with .NET. So you guys, like we can set up, these are some of the things that are mentioned. We can set up the Redis server in our .NET project or maybe in Java project as well. We can download this Redis server. By default in .NET, we have in-memory cache that we can implement. But for Redis cache, we need to use, we need to install the server for that to work on our local. So now we would be proceeding to implementation and demo part. So Sujit would be like demoing it. So
Yeah, sure.
yeah, sure, Sujit. Just a minute. Yeah. So this is how we can connect to a Redis cache. Once we download that Redis, we we need to use that library. We need to configure it. So this is how, this is just a sample code. Basically, we need to connect to our local host for now. So this is how we can connect to, like, this is a connection multiplexer class, and this will create our that Redis connection, and this will create a like a get database call. So basic operations are set and get. So implementing cache in .NET microservices, cache aside pattern, the pattern where the application first check the cache before querying the database. So sample code, this is kind of a sample code itself. So let's say I'm making a hit to retrieve data, to get data from cache. I mean, just a sample code. I'm feeding a key. Thereafter, like feeding the key from my DB call, I'm getting that particular value. If I don't get that value from my cache, what I will do, I will go to my database. In the get data from database, I would retrieve that particular value and then return it. And accordingly, if what technique I'm implementing, maybe after retrieving from database, I can store it in cache as well for the next time. So these are implementation, like how we can implement it. These are some of the libraries and the Nugget packages that we need to install. So basically, the conclusion is like Redis is a distributed cache, significantly enhances the performance, scalability, fault tolerance, and provide fast access to our in-memory data access. It reduces database load. It improves response time as well, because if I get the data from cache, the response time would be faster. It would ensure high availability, because at most of the time I would be available. There would be no database hang calls or something like that, with features like replication and failover. By integrating this Redis with a .NET Core, maybe Java as well, developers can build efficient, scalable, and reliable microservices. It would maximize the benefits. It's crucial. Best practices are like cache invalidation, expiration. We need to make sure that we if the data is invalid, we need to make it expire as well. It's not like that that data is in that cache memory for 1 year or 2 years and the data is already updated in database. We need to make sure that what is the business use, we need to set the expiry time of the database as well, and accordingly monitor it. So yeah, this is about distributed caching. Now we would be moving to implementation part. Sujit, I hand over to you. Please move ahead.
Yeah, sure. Thank you, Ajit sir.
Yeah, thanks, Sujit.
Yeah. Please confirm that my screen is visible or not.
Yeah, Sujit, your screen is visible.
Okay, sure. So hello everyone, good afternoon. I hope everyone is well. So let's start with the demo part for this cache. So I just made four basic steps for it. First of all, we have to download and install the Redis. So after installing the Redis, we have to start Redis server. So for example, I have started this server on 6000 port. You have to do, you just have to go to command line, and actually what happens is that you have to install like WSL for that. I mean, it's not mandatory. Redis also runs on a Windows, like it also have that executable package. But actually I'm doing right now, I just running it on the Linux. So for that thing, I installed WSL here, and I started the Redis server on the port 6000. You can choose any port you want. The second step, what we have to do, we have to install this package from the NuGet packages. So if I go there and if I just have to install a NuGet package, so what we have to do, we have to go there to manage NuGet packages, and we have to search for that package. So this package, this one. So we have to install it. We have to install this package to connect with the Redis server. And then the third step would be we have to do a configuration for the Redis cache. So like what we have to do, we just have to add our port over there. So whatever port the Redis server is running, we have to add that port. For example, I started Redis server 6000 port. So I will go to my application and I will tell that the Redis server is running on 6000 ports. So where we have to do, we just have to go to here. Wait a second. Yeah, this one here. And we have to tell that the Redis server is running on 6000 port. This one. And the last step would be the implementing. So I just added some basic code for it. I don't want to go in very depth, like because I don't want to make it very complicated. Just the basic stuff I want to talk about. So what I did actually, basically, I created a variable. So for example, let's say we are having this kind of data. So I just initialize some three variables over here. And what I will do, so like the first thing, we have to check if the cache is present, if the data is present in our cache or not. So for that thing, we have the cache key, and we are just sending the cache key to our distributed cache. if the data is found inside our cache, then what we are doing, we are just serializing, and uh, that means the cache hit is happen over here. So we are just deserializing the cache data over here, and we are directly sending it. We are directly returning that data from the cache itself. But in case if that data is not present inside the cache, so that means that will be the cache miss, and we have to go to the database. So for example, for the simplicity purpose, I actually made a one method over here. So just to mimic that we are getting the data from database. Actually, just this is just a mimic method. For that, I'm just using it. And then after that, we are just processing the things over here, and then we are setting the options over here. So for example, here you can set the expiration time of the cache, and the this is also important, the set sliding expiration. So this thing is something like if the cache will be the expire if cache is not accessed for a particular time. So for example, I just added 2 minutes over here, and then we are just sending the things over here. So if I go to the, like, if I run this project.
So as we can see on the line number 63, we have set up the expiration time as Sujit is showing
Yeah,
up.
yeah,
So
yeah.
that is expiration time of that particular key and value pair. You can consider it like this for now. 10 minutes is the expiration time. After 10 minutes, that particular key won't be available in the cache. And this sliding expiration is something that if it is accessed frequently, I mean to say for like if not accessed for 2 minutes, then it would like expire
Yeah.
ultimately.
Yeah, so I run this project, and the Swagger is open. So this is running on 4.4.3, and the endpoint is weather forecast. So I'm testing it from the Postman itself. Let me clear this one. So in the Postman, what happens? Let's say whenever we are sending requests for the first time. So of course, the first time the data will be not present inside our cache. So it will take a lot more time because the data is not present to the cache, and that request have to go to the database and get the data from the database itself. And then when we do that, it will also store the data inside the cache. So when we hit for the second time, like when we hit this request for the second time, we will not get that time, we will not require that time, because now in the second time what will happen, like this request will go to the cache itself. In cache, it will got the data over there, so that is a cache hit, and then it will return back that data. So on the second time, when the cache is there, it will not take that time. So for example, I'm hitting this endpoint for the first time, so it will take much more time. If you see over there, this one, so the time it took is like a 1519 ms, like it's millisecond. And let's say for an example, I am hitting this request for the second time, it will take a less time. Just see over here. So let's say if I was hitting this for the second time, the time actually has been reduced, because the second time this data is coming from the cache itself. This data was stored inside the cache. So and also we can do debugging over here if you want. But yeah, that's the thing that is happening. That's the overall picture is happening inside the cache.
Yeah. So it signifies itself that the data access time is very fast.
Yeah, yes,
We are
yes,
able to access the data in milliseconds. Yeah.
yeah, yeah. Yes, sir. I'm done with the demo.
So is it done, Sujit? We are
Yeah,
any
yes.
yeah, okay. So yeah, Himanshu. So that is it from our end. So this was the demo that was showcased by Sujit. And thank you so much, Sujit. So team, to close it off, I would say this Redis cache, as we can in the example we have seen the how we like expired the cache as well. We have also seen that the access time was very much reduced. If we make a database call, it would let's say it would give us in 10 seconds, but from cache it has given us in milliseconds, something like that. Just an example. So yeah, thank you so much, team, for everyone for attending this, and thank you, Himanshu, for arranging it. Yeah.
No worries. Thank you, Sujit, and thank you, Ajay. Yeah, Anshuman, you're about to say something.
Yeah, I have a few questions. Like we
Sure,
are
you can.
using Redis, right? So at the first time we are calling the database directly, and then after that we are saving it in a Redis cache, right?
Uh,
Let's say the database is RDBMS, like relation database, and and we are fetching it and saving in the Redis cache. So how that data saved in Redis cache, and what is the key, like how the next time we are going to fetch that? Let's say at first time we are fetching from the first name. The second time we are fetching with the email ID. So how Redis is going to identify like is the data is available in the Redis cache?
Okay, fine. So coming to your question, Anshuman. So in Redis cache, like when we store the data, we would be identifying on basis on some of the keys, like if that particular data or maybe some key or ID. It's not like that if you search something. It depends on the business. See, if you're searching something maybe on your Google, you are searching cricket, something like this, and you're expecting that bad ball would give you the result from Redis cache. I mean to say cache itself. It depends if we have stored that particular kind of thing into the cache memory, and if we can give the same result out what we gave in with the cricket keyword, whatever the result we gave from the cricket keyword, can we render the same result if we are searching ball or bat, something like this? We will go to the cache, we will identify it, all business. Then accordingly, we would throw the data onto the page. Coming to how we store the data, that is also a business. We can, on our very first call, if the data is not in cache, we will store it in database. And thereafter, as soon as we store it in database, maybe at that particular point of time only, we can store it in database as well and cache as well. Otherwise, we would just store it in database. But when the next time when we come, we would make a hit to database, retrieve the data, store it in cache, and throw it to the user. If the third call comes, we need not go to jump to the database. From cache itself, we can identify, yes, data is there. We need not make that RMDB call. We would just retrieve the data from cache and throw it to the user.
Okay, and
Yeah.
for the distributed cache, let's say we are retrieving for that Redis database, and
Uh,
some other one is going to update the database itself. So how our Redis will be get know that this has been updated?
Exactly. So again, that's why that expiry time came into the picture. Let's say there is some chunk of data that is there in the cache, but now we know that that particular chunk of data would be expired. I mean, sorry, would be updated in some time. So we would be expiring that data. We would set some kind of expiry time, maybe 2 minutes, 5 minutes, or maybe 1 day. Accordingly, all business. I mean, we can think it of like this. That we are accessing some data, but we know at every other day there is some kind of job that would run and that would update the data. So we would set the expiry date to be 1. So the cache would know that I need to expire this. We have some kind of techniques that I went through. Least recently used FIFO, LIFO. These kind of techniques are there. We can make use of it. Empty our cache. Otherwise, we can set our expiry time. Next time when we go to the cache and we don't find the data because that is expired, we will get the updated data from database itself. And Redis
Okay,
would come.
so you are saying like until unless we don't expire the chunk of data which is already present in Redis, we won't be able to get the updated data in from the Redis.
Yes, because let's say if I have configured my code something like this, whatever you are getting, I mean, whatever the data that I'm retrieving, I need to jump to the cache first. And if I can find it
Right.
in cache,
So,
why would I go to the database, right? But in cache, maybe in cache, I have there are some functionalities in the updated package that have come. Maybe in cache, if I find the data, I will throw it to the user. But the data is not updated according to you, which is very fine. But the data was stored in cache. Maybe I have set some kind of date over there, some kind of logic over there that this data need not be thrown to the user after this particular date. This is there in
okay.
the latest package. I can
I guess
handle it like
I guess if I'm not wrong, there is some communication link between the cache and the database. It automatically get the updates. No worries, we'll look into that.
yes, yeah,
Thanks,
sure.
Ajay. Thanks,
Hmm.
thanks.
Thanks, Anshuman.
Yeah.
Okay, so are we having any other questions, guys? No questions? Okay, fine, fine. Before we part ways, so I'll just take a moment and will ask everyone, every attendee of this session to please fill out the forms. Then uh, because it is really helpful for us to get the inputs for the future session improvements, and certainly we have been getting the feedbacks that the sessions are not going by your expectations. So that's the whole insight that we want to take care of. And if you are not going to fill the feedback form, so we'll not be able to improve on the future course of action. So with this, I'll just wrap up this session. And thank you, Sachit, and thank you, Ajay, for delivering the such an insightful session. And thank you, attendees, for joining this session. I guess you have a great weekend ahead.